slide.
Okay.
Couple announcements. So for Cyber Academy this Monday, we have a pretty cool talk by Vera. Where's Vera? Vera has a cool talk tomorrow, or sorry, Monday for OSINT. If you want to learn how to do cyber stalking, that's pretty cool. Ethically, of course. This Wednesday for Cyber Lab, we have a pretty cool talk on hardware security. If you want to learn about this hardware security side channel attack called Starbleed. I think it's based in like the biggest target is in like satellites. So if you want to learn more about that, one of our members, Anderson's also giving a talk this Wednesday. So come if you want to come learn about it, come check it out. For cyber, we have a club social next Saturday at Santa Monica. We'll have more information this week, but basically we're going to Santa Monica. Get your Bruin tap card if you want to come join us. It's the tap card's free. We're going to go to the beach, hang out, boardwalk, etc. NSA Codebreaker is going on right now. If you don't know what this is like a competition run by the NSA. So if you want to help UCLA get to the top of the leaderboards, to help out with this, you just need to solve challenges with us. We're talking about this in one of our channels on the Cyber Discord. So if you want to get the NSA Codebreakers role, just go to channel roles and grab it as well. But okay. Without further ado, I'll pass it off to Alex to start his talk on pwn, which is binary exploitation. So let's give it up for Alex.
Okay, so then we're talking about pwn. So
yeah, that's fine.
Okay. So next. So pwn is a category of CTF challenges about like exploiting vulnerabilities in the binary programs. So like vulnerabilities might include like buffer overflows, format string vulnerabilities, heap vulnerabilities. So like buffer overflows are like most basic type engine, like very common. And like programs are like usually written in C because it's like it's a really common language for like compiled software, and it's also very unsafe. So like it's very easy to end up with like the kinds of vulnerabilities that we can exploit. And like by gaining control of the program, we usually mean like getting it to like print out a flag, or like turning the program into like a shell so that we can like do whatever commands we want. So the way it works is that usually we have a server that will be running the binary, and the server will have a flag, and we have to like connect to the server remotely, export the binary, and get the flag from the server. Okay. So this is what a typical challenge looks like. So you see the NC LACTF 31180, that is the address of the server. So that's why you have to connect to the server. And then they give you the program that you want to exploit. And then sometimes they also give you the source code, sometimes they don't. So you have to reverse engineer it. And they also give you like some like libraries and stuff that's needed for like running the program on your local machine. So here's a demo just to show the basic concept. Okay. I need to unlock. So let's say we have a challenge called applet 123 for some reason. So we have okay, so we have like a program called applet 123. That's this one. So we can like run it, and it says, "Hi, I'm applet 123. How can I help?" And then looks like it's waiting for some input, so we can like type something. And it does not give us the flag, so you can try like running it again. And yeah. Okay, so like if you look at the source code, you can see so we have like a print flag function, which is probably like something that we want to like use.
We can know.
Is that better?
Is that-
Okay, and then we have like a bunch of strings. Okay, so we see we have like our main function, and then so here it prints out the hello string, and then it reads our input using this function called get. And this function is like a very old like C function that's like has been removed. But what it does is that it reads input into like a buffer inside memory, and it does not check if the input is bigger than the buffer. So like if you give it some string that is longer than the buffer, then it will just like overwrite memory past the buffer, which is like very useful for us since we can like corrupt memory and make program do stuff that it's not supposed to do. And then here it just like prints out the response, which is not useful for us. So now, like I said, like gets does not check if the input is like longer than the buffer. So like if we put a really long string, then like you notice we have segmentation fault. So that means that we have corrupted memory. Now the problem is how do we like corrupt the memory in a way that makes the program give us the flag? So here I have a file called like exploit. And if we like print out exploit, you see it's just a bunch of A's followed by some weird things. You can like hex dump it to see that we have a bunch of A's, and then we have like a couple of bytes that aren't printable characters. Now the thing is, if I do run this program and then I have the exploit file, so like if you're not familiar with Linux, that means that I'm taking the contents of the exploit file and then I'm feeding it to the program. So if we give this data as input, then you see some interesting things happen. So we see that program still crashed, but it printed out the flag. So yeah, so the way an exploit is that we have to analyze the program to figure out basically the memory layout and the addresses of the print flag function. So I'll show you on the next slide. So basically in the program, we have like some memory called the stack. That's where like local variables are stored. So on the stack, we have the buffer. So that is where our like input string is stored. And then there's some like other stuff that we don't care about. And then it should say return address there, but it looks like the font changed a bit. And yeah. But where can you go back? So like this here is like something called the return address. So when you call a function, the code needs to know like where to continue executing after the function returns. So basically when you call a function, it pushes the address of the next instruction after the function call onto the stack, which is so when the function returns, it will like jump to the address that's on the stack. So that way it can continue executing where it left off before the function call. So what we did was that we put if you just next, so we put like a very like long string into the buffer, and then it like overflowed past the end of the buffer, and overwrote like the other stuff that we don't care about, and then it overwrote the return address. So what I did was that I put the address of the print flag function where the return address was. So we overwrote the return address of the print function so that when the function returns, it will jump to the print flag function instead of where it was supposed to return. And that's how we printed the flag. Yeah. So it's okay if you like don't completely understand this. It's just to mainly demonstrate the concept of Pwn challenges. So Pwn is a category that kind of requires a lot of like prerequisite knowledge. So not going to be like going over all of them because that would take forever. So I'm just going to give an overview. So first of all, it's really good to know assembly language. So this is a textual representation of binary machine code. So when you have a program written in a language like C or C++, it is compiled to binary instructions that can be directly understood by the CPU. And assembly is a way to like represent these instructions so that it's like a little bit more human readable. So you see, like it's just a long sequence of instructions. We have some call instructions that use call functions. Move instructions are used to like copy data inside these things called registers. Registers are where like we store temporarily store data that we're working on. So you need to like knowing assembly is like helpful for like understanding like exactly what the program is doing at like a low level, and because like we're going to be like doing stuff like corrupting memory and like overriding addresses and stuff, you kind of need to understand like that. So next would be C, because well, a lot of challenges are like almost every challenge is like written in like C, like for reasons that I said before. So sometimes they give you source code, so like if you know C, you can like understand what the program is doing. And also, if they don't give you source code, like you have to reverse engineer it. So yeah, like a lot of times they give you like a binary program, but not source code. So in this case, you kind of need to know reverse engineering, and like that is like a whole other CTF category on its own. But basically, you use tools such as this is a Giga. It's a reverse engineering tool made by the NSA. There's also other tools like Binja, but it costs a lot of money.
Binja Cloud.
Oh yeah, I guess okay. There's like Binja Cloud, which is like free, but yeah.
Can you spell these?
Ghidra is GHIDRA, and then Binja is binary ninja, BINARY space NINJA.
If you're doing eCTF, you don't need these.
Okay, so like you see, like here we have assembly code, and then what like Ghidra does is that it decompiles it. So like it gives you like some code here. It looks like source code. It's not like exactly C, but it's a kind of similar representation and helps you understand what the program is doing. Next. Also, Python is really useful because we use it to write solve scripts. So you know, like in the previous example, like I just had like export file that I just like input like inputted a file to a program, but like most of the time you want to do like more complex stuff. Like sometimes you have to like communicate with the program interactively, and yeah, so it's useful to have like scripts to do that, and we use Python for that. Also, GDB is the new like debugger. So like most of the time, like a lot of the time, like exploit is not going to work like the first try. So we use GDB to like step through the program like one instruction at a time, so we can like see what is happening and help debug our exploits. And also it's like useful for like reverse engineering and stuff, because you can see what the program is doing. You can see like the registers on top, and you can see like here's the staff that shows like the memory there, and then the instructions. So so here I have a GDB extension called Jeff. That's GEF, GDB enhanced features. So it shows you like a lot of extra useful output. Yeah, like by default, GDB won't show you any of that, like manually print them out. So okay, so now I'm going to talk about Pwn tools. So this is a Python library for writing exploits, and it has a lot of like very useful things. You usually just do like from Pwn import and asterisk, so that means like import everything. So for example, like one of the useful stuff is like communication. So how to like have your script communicate with the program. So if you usually they have the program like you test your program locally, you test your exploit locally. So you give it like process, so you call process with the file name of the program and then like some arguments if you want, and then that will run the program locally as a sub process, and then you can like communicate with that. Or like you could do remote, so that means like connect to a remote server. So that's typically like how you're gonna actually like do an export on server to get the flag. You can do things like send bytes, and then you can like send line that just automatically has a new line at the end. You can like receive line, and receive until, so like that will receive bytes until it sees like a certain byte sequence. And then you can also receive like our main data and then like receive data until like no more data arrives for some time. So those are useful for like different scenarios. So we also have functions that convert integers to bytes. So like when in our soft scripts, we typically like represent addresses using like just like basic Python integers. But like when we communicate the program, you have to like send them as like raw bytes. So we have functions like P64, P32. So like that converts the integers to like a 64-bit like byte string or like 32-bit. And like it does like stuff like, if you're familiar with like NDNS, basically all like most like modern machines, like the bytes of the integer are like, actually stored in like reverse order. So like P64 and those functions will like, automatically reverse the bytes for you. And the opposite will be like U64, U32, etc. So that takes like a sequence of bytes and it converts it back into a Python integer. Okay. Also, we have functions for like analyzing ELF files. So ELF is like the binary format for Linux, and like almost all challenges use like Linux. So yeah. So we can use things like exe.symbols.function name. So like if you put like any function name in there, it'll tell you the address of that function. So for example, like in earlier challenge, if you do like exe.symbols.print flag, that's the address of the print flag function which we want to like hit. You can also like search for bytes in the file. So exe.search, that will give you like an iterator that tells you like all the occurrences of the certain sequence of bytes in the binary. And you can also like look at things like the global author table or procedural linkage table. These are like slightly more advanced things that is going to be useful for like binary explanation. Yeah. Other features. So return-oriented programming, also called ROP, is technique for it's a general technique for like exploiting binaries. It's a lot of challenges are like ROP challenges, and Pointers can like help you do ROP like semi-automatically. You can automate a lot of the small parts, so to make your life a lot easier. You can also do like formatting exploitation, which is another like more advanced like category, and also shellcode generation. So like it can automatically generate like machine code. So like for some challenges, you can like it's possible to like inject code into the memory of the process and then cause that code to be executed. So it can automatically like generate code that will like, for example, do things such as like spawn shell, which will give you like So also another tool is pwner. So basically like most binaries are like dynamically linked. This means that they you need like separate library files that the process like links to at runtime. So basically when you download usually like the challenge will give you the binary and also like some libraries like like libc and like ODB. Now if you just like run the binary like without modifying it, what it will do like is that it will use the libraries on like your system, which are probably not the same as the libraries that are on like the remote server. So you want to like make sure that you're using the exact same libraries at the server so that you're executing the program like the exact same way, because in many cases you're gonna have to like use exact addresses in the libraries and stuff. So you need to make sure you have the exact same files. So pwner automatically like modifies binary a bit so that it will use the libraries that you want. Yeah. So more tools. So Linux, like I said, most challenges, like almost all challenges are Linux. So you're gonna need like some sort of Linux environment. There's like we have like the CTF dev container, which is like kind of being built on like GitHub like containers, GitHub code spaces, where you can like connect to a remote like container to do some of the stuff. I would like if you can, like I would recommend setting up a Linux like virtual machine to do challenges. If you're Windows, WSL might work for like some stuff. Not sure. If you're Mac OS, then I don't know. Probably virtual machine, but yeah. Also Docker. So Docker is like a tool for like bundling code. Basically, if like you can make a container that has like all your like program and like all the stuff that it needs, like all the libraries. So like a lot of times they will distribute like challenge files to you by giving you like a Docker file. So like sometimes you need to like use like Docker to like get the libraries from Docker container. And like so there's DEADFACE for reverse engineering. And there's a tool called checksec. So there are different like kinds of these things called exploit mitigation. So like I said, like buffer overflows are like really common vulnerabilities. So people have like followed ways to like kind of protect against that. So there are different things such as like these things called stack canaries, like ASLR. There's just these different like mitigations that are like at compile time, and checksec is a tool that you can use to figure out what mitigations are in use, so that like will affect how you're going to exploit the program. Also, there's GDB and Dev for debugging, like I said. Yeah. So now we're going to have a practice challenge. This is like a really basic challenge that hopefully should be like solvable even if you don't have experience. So, okay. So first of all, we have the ncplatform.acmcyber.com 10337. So this is like a server address. So we can like, if you're on Mac OS, I think you should have NC. If you're on Windows, then you have to use the CTF container or something. So, if you connect to the server, you can see that we get some like output. And then basically, the goal is to like figure out like what input you can give to this program that makes it give you the flag. And so I'm going to show you like the CTF containers. So if you click this link, you'll see like a GitHub repository. And if you just like click this button, open and GitHub code spaces. I'm gonna do this in Firefox. What? I'll put it into this one. So wait. So if you click the open and GitHub code spaces button on this repository, you'll see like this, and just like click the create new code space, and like I guess I'll do it now. It might take a little bit. Yeah, it might take a while. It's the first time you're doing it. I think like I've done this before, so it might be faster. I'm not sure. Yeah, but okay, yeah, I guess. Sure. And also, I'm going to send the program and the source code, which will be useful for this. So here's the CTF container, and these are the files. So chow is the program that you want to exploit, and then chow.c is the code, source code. Yeah, so let's see, CTF container is set up. Oh, it's still wrong, yeah. But yeah, so like once you're in the container, you should see like a VS Code like interface, and there should be like a terminal there that you can use. So yeah, once you have the terminal, you can like do this to connect to the server. You can also like run the program locally. So going back to the slides. So like I sent like the program in Discord, so you can like inside the CTF container, you can like right click in the file explorer and upload to like upload the program onto the container, so you can like run it there if you don't have like Linux on a computer. And yeah. So yeah, you can like try solving this. Yeah, so that is like the end of our presentation.
Okay. Thank you, Alex. Let's give it up for Alex. Sorry, are there some questions for Alex, or?
Yes.
Yeah.
Connect to the goal space after we set up. But try to run on the NC platform.
So like for your Mac OS, right?
Yeah, I'm a Mac.
Or like I think you might have NC already. Like
Pretty sure Mac has this.
wait, if you run that command, do you see the output from the program? So if you run this command, like do you see the output from the program?
Yeah.
Wait,
Does it say, like-
what Wi-Fi are you on?
Uh,
Are you on UCLA Web?
Yeah.
Okay,
Oh,
switch
yeah.
switch to Edgy Room.
Oh,
UC,
Yeah, you see like logs stuff that's not like regular websites. So
any other questions for Alex? Okay, so what are your that's fine.
yeah.
One of some of the events that we are doing at ACM Cyber, one of the things we're doing is a game hacking lab. And this is a game hacking challenge. So that's pretty fun.
Speaking of which, game hacking.
Yeah, that's a promo.
Okay, so
I hope that's the game and went, oh, that's funny.
It's the only one who's
wait, okay. Oh wait, I guess this is still connected to my computer. So
That they says.
wait, do you want to like connect this to
Challenge.
Search, like we just open in tiles.
Yeah.
Ignore my memes that I send on Saturdays.
All right, I'm coming over here.
Besides getting a lecture.
All right. So for those of you who are playing DEADFACE CTF, we're gonna later split people up into teams of 4 since they have a team size limit. Oh, it's 300. It was 50 last time. Awkward.
Okay, now we're really shooting.
All right, interesting. Oh, I think they wait. No, it's not. It's 50. I don't know what happened there. All right, interesting. So basically you're gonna, go on DEADFACE, you're gonna create a team account with a team, you're gonna join the team, etc. And you'll see a bunch of these different challenges. And I just went through and I solved a couple of them last night. Yes.
Can you stand like you're blocking the projector? Can you just stand so that we can Alex?
It's better. All right. So yeah, all the challenges are categorized. Like you have reverse engineering, programming, cryptography, pwn, like Alex just talked about. So I'm just gonna do a quick reverse engineering challenge. I saw this one and I was like, this is funny because this is kind of what we are doing with the game hacking stuff. Figured it would be fun and applicable. I already downloaded the game, but essentially they tell us there's a flag hidden in the binary that can only be accessed by entering a cheat code that's used as a secret password. All right, cool. So let me go and open the download. Yeah, so this is the game. We can play the game really quickly just to see what it is. This one. So I'm gonna let that boot up. But before, like while that's happening, I'll talk a bit. Unity games are built in C#, which is then compiled down to an intermediate language. It's not compiled down to machine code like Alex was talking about with like, C and C++. And then, yeah, I don't know what they did with this game. It's like a platformer. We can jump, we can do stuff. We can type some stuff in here. And assuming, yeah, interesting. We could type some stuff and I guess if we type in the cheat code, we will get a flag. Cool. All right. I don't want to play the game anymore. All right. It's not, but that would be fun. Spoiler, it is not. But yeah, so Unity games, again, C# compiled down, and then they're also dynamically linked. So if we go into like the data file, then the managed folder, you see a whole bunch of DLLs. A lot of these are Unity engine DLLs, so essentially how Unity handles stuff like, mathematics and graphics, etc. But then you have this assembly C# DLL, and that's the stuff that actually contains like, the classes and things for this specific game. So this is a little bit of a, I'm going to show another tool as well, just because I can. But then I'm going to give like a little bit of a spoiler to the people who are doing the game hacking project for something we haven't covered yet. But yeah, this is Cheat Engine. Cheat Engine is just a program that it attaches to another process, and then it's able to go through and debug memory for that process. So I can attach to this, and now it's attached to this process. Because this is a Unity game, it's C#.NET, you have this extra mono tab in Cheat Engine, where you can go through and kind of see class information. Again, this is because it's not compiled fully down to machine code, so you get some extra information. So we can see again here, these are all the DLLs I kind of showed you in that folder, and Cheat Engine also has access to these. So if I want to take a look at assembly C#, for example, you could see there's a bunch of classes. Is the text too small? I don't think I can actually change the text size, unfortunately. But wait, actually, I can do this. 1 second. But yeah. Also, if any of this stuff interests you, like, feel free to talk to me about it. There we go, that's better. All right. So yeah, here's this. You can see these seem to be a bunch of different, like, class names. We have a couple that seem interesting. We've got cheat code with this flag text variable. Unfortunately, we cannot just go through and see the flag text because you can go through, you can kind of look up instances of the classes, and Cheat Engine will try to figure out what is what, but you can see there's a bunch of different addresses it thinks that this class is at. And then we have, that's cheat code. We've got flag check that also has some stuff, some static fields, some regular fields, and then some functions down here. Cool. All right. I could do this challenge fully in Cheat Engine, but it would take longer. So I'm not going to do that. Instead, what I'm going to do is I'm going to close out Cheat Engine really quickly. And I'm just going to open up a program called DNSpy. There are several programs like DNSpy. All that it is it's like a .NET decompiler. So what it does is it'll take in a DLL, and then it will try to take that from the intermediate language back up to C# or up to Visual Basic or something like that that compiles down to an intermediate language. So this DNSpy is Windows exclusive. There's also ILSpy, Avalonia that are doable for Mac. But most game hacking tools are much better on Windows. So I tend to use that like pretty much exclusively. I'm going to close the game again because we no longer need it, and it kind of creeps me out, to be honest. All right. So I'm going to load up DNSpy, and I'm just going to plug in. I've already plugged in the DLL. Oh, spoiler. I've already plugged in the DLL. But like what I'd do normally is I'd go File, I'd go Open, and then I'd go to the managed folder that I showed you earlier, and I just grab out assembly C#. And this gives us a lot more information than Cheat Engine gives us, because it actually goes through and it kind of rewrites this stuff in C#. Like you can see here, I'm in the camera controller function. This is actually like legible code. Whereas if I were to try and look at this in Cheat Engine, you would be looking at much lower level like assembly stuff. Good learning experience, but this is easier and takes less time. So we can see if I put up the cheat code class, the cheat code seems to just give me the flag. Nice. So I could go in and I could type that into the game, but I can also just scroll down a little bit more. And there's the update function that goes in and kind of checks, did you type in the right cheat code? And then just spits out the flag in plain text. So that's it. We can also go, we can go back to the game and try this out as well. I'm typing. There it is. Yay. So then what you would do normally is you would go through back here and you would put the flag into this submission. I've already submitted it and I have already. Oh.
Hey, do it yourself.
Yeah, do it yourself. Do it yourself. You want to get the tutorial again? Here, you guys have like 5 seconds. Wait, I have 2 of these open. Yes. It's 50 points. It's 50 points. It's not a big deal. So take a photo and send it over. All right. But that's how a lot of CTF challenges go. This one is specific and like the tools that you use. You might be like, I don't know any of these tools, so this would take me longer. That's okay. What I recommend for these is like, you know, we'll be trying to pair you with someone who's more advanced, knows some stuff, but also write-ups for previous challenges are very useful for figuring out resources. We have the PBR wiki that helps with that as well. And just feel free to talk to your teammates and talk to other people
Salma,
for help. Yes.
did you try running strings on the binary?
Oh wait, I could have probably just done that.
Wait,
It's not a binary. That's an executive. Let's find out. All right, let me see if I can run strings because normally it was very weird to me. They stored the flag in plain text. Sorry, this is
Sound like video.
awkward. Oh, wait. Sorry. Yeah.
The strings don't capture the whole flag. The flag doesn't hear it.
Mhm.
We're
The
testing
flag-
it out.
yeah, let me
Sometimes in
see.
binaries, they just like, if you have a string, like strings, what the command string does is that it extracts all plain text strings within the binary. So oftentimes you can solve a lot of like beginner challenges this way, if you just throw the flag in plain text. But we'll see if this is true
Oh.
here.
Which one is it again?
Isn't it the ASM?
Yeah, it's the 3D platformer. Oh, let me grab it. Wait, hang on. Yeah, grep. Also, fun fact, if you don't know what grep is like the control F of Linux. Oh wait, where is it?
Probably in the
Yeah, I think if you were to do, hang on, let me see if I do this with the DLL. I don't know if I'm able to just do that. Oh, no, okay, so yeah. Unfortunate.